Friends, engineers and architects and HVAC consultants and designers, students. Welcome once again into VK Jain Sir ki MEP classes. In this particular module, we are going to discuss cooling towers that are used in HVAC application. Friends, this is a schematic diagram of a cooling water system. Let us take first the cooling water tank. This cooling water tank has arrangement for water spray, water that is coming from condenser, warm water is spraying downwards, and the air is coming from bottom. It has got a cooling tower tank, water tank, from where ultimately the water is pumped back to heat exchanger, and from heat exchanger, that is condenser, and from condenser it comes the hot water which is sprayed here. Some portion of this water droplet gets drifted up, and that is evaporated. We have to have a makeup water tank which is on the top of the building, along with this uh, the cooling water tank. Friends, through this schematic diagram, will be able to understand the theory of cooling tower. This is the cooling tower vessel, and some portion of water in this system is supplied through makeup water source. This cooling tower, the water comes from condenser through pumps, which is hot, and it is cool in the cooling tower, and this cool water once again brought back to condenser, start of the condenser. In the cooling tower vessel has got a system for inflow of natural air inside. Friends, cooling tower are used to dissipate heat from the water cool refrigeration, air conditioning and industrial processes system to atmosphere. Cooling is achieved by evaporating a small portion of recirculating wire, water into outdoor air stream. Cooling towers shall be installed at a place where free flow of atmospheric air is available. They can be either on ground or on top of the building. The range of cooling tower is defined as temperature difference between the entering and leaving water approach of the cooling tower is the difference between leaving water temperature and ambient air wet bulb temperature. Now, these two definitions are necessary to understand the theory of cooling towers. Uh, this is These two terms are required for selection of a particular type of cooling tower. Friends, now we are discussing component of cooling tower. The basic component of an evaporative cooling tower are frame and casing, fill inside, filling material, cold water basin, drift eliminators, air inlet, louvers, nozzles, and fans. About frame and casing, most towers have structural frames that support the exterior enclosures, that is casing, motor, fans, and other components. With some smaller design, such as some glass fiber unit, the casing may be essentially the frame. We need a filling material through which the water uh, gets down from top of the hot water is circulated from top, and it goes slowly up to bottom through a fill material which may be made of plastic or wood to facilitate heat transfer by maximizing water and air contact. Fill can either be splash or film type. With splash fill, water falls over successive layers of horizontal splash bars, continuously breaking into smaller droplets while also wetting the fill surface. Plastic splash fill promotes better heat transfer than the wood splash fill. The film type fill consists of thin, closely spaced plastic surfaces over which the water spreads, forming a thin film in contact with the air. These surfaces may be flat, corrugated, or honeycombed, or may have other pattern as well. The film type of fill is the more efficient and provides some heat transfer in a smaller volume than the splash fill. Matter to be continued. At the bottom of the cooling tower, there is a cold water basin. The cold water basin located at or near the bottom of the tower receives the cool water that flows down through the tower and fill. The basin usually has a sump or low point for cold water discharge connection. In many tower designs, the cold water basin is beneath the entire fill. As per National Building Code 2016, in general, the calcium hardness in the cooling tower makeup water should be maintained within the range of 350 to 400 ppm on a non-acid treatment program. If the makeup water contains 100 ppm calcium hardness, the cycle of concentration are restricted to 3.5 to 4. This is equivalent to 75% to 85% water efficiency. Friends, two terms are often mentioned in selection of cooling tower. Range. The range is the difference between the cooling tower water inlet and outlet temperature. Here, this is the hot water temperature, and the range is between this and cold water temperature out. This is hot water in. And approach is the difference between the cooling tower outlet cold water temperature and ambient bed valve temperature. Although both range and approach should be monitored, the approach is better indicator of cooling tower performance. This one. Friends, the cooling tower effectiveness in percentage is the ratio of range to the ideal range, that is difference between cooling water inlet temperature and ambient wet valve temperature, or in the word it is range divided by range plus approach. Cooling capacity is the heat rejected in kilocalorie per hour or TR tons given as product of mass flow rate of water, specific heat and temperature difference. Evaporation loss is the water quantity evaporated for cooling duty, and theoretically for every 10 lakh kilocalorie heat rejected, evaporation quantity works out to be 1.8 cubic meter. An empirical relation used is evaporation loss in meter cube per hour equal to uh, 0.00085 multiplied by 1.8 multiplied by circulation rate in meter cube per hour. Now we'll discuss friends selection of cooling tower. Following factors shall be considered for selection of cooling tower. A. Design wet valve temperature and approach of the cooling tower are already defined. The designer shall endeavor for reducing the approach for maximizing the energy conservation potential. B. Height limitation and aesthetic requirement. C. Location of cooling tower considering possibility of easy drain back from the system. D. Placement with regard to adjacent walls, windows, and other buildings, and effect on these from any water carried over by the air stream. Next, vibration and noise level, particularly during silent hours, that means in night. Next, material of construction for the tower. Next, direction and flow of prevailing wind. Next, quality of water used for makeup. Next, maintenance and service space availability and ambient air quality. The recommended floor area for various type of cooling tower is as given below. For natural draft cooling tower, it is 0.15 to 0.2 meter square per tonnage. For mechanical draft, it is 0.07 to 0.1 per square meter of tonnage. certain amount of water is lost from the circulating water in the cooling tower as given below. It is divided in three portions. Evaporation loss. It is usually about 1% of the rate of water circulation. Second, drift loss. The drift loss shall be below 0.1% of rate of water circulation. Third, blow down or bleed off. The amount of bleed down shall be below 0.8% of the total water circulation. If simple blow down is inadequate to control scale formation, chemicals may be added to inhibit corrosion and limit microbiological growth. Also, provision shall be made to make up for the loss of circulating water through backup water tank. Friends, the provision for makeup water tank to the cooling tower has to be made compulsorily. Makeup water tank to the cooling tower shall be separate from the tank service drinking water. First, makeup water should be sourced from a treated water from the sewage treatment, wastewater treatment plant, or from rainwater harvesting. Makeup water having contaminants or hardness which can adversely affect the refrigeration plant life shall has to be treated. Treated water where hardness as ppm of calcium carbonate is reduced to 50 ppm or below is recommended for air conditioning applications. Water with the pH value less than 5 shall also need to be treated. Friends, heat transfer is proportional to the surface area over which it occurs. A splash fill is used to increase the surface area between the air and water flows. The makeup water source is used to replace water lost to evaporation. Hot water from the heat exchanger is sent to the cooling tower. Friends, there are two different techniques to have airflow generation. First one is natural draft and second one is mechanical draft, and these two diagrams shows them respectively. In case of natural draft, warm air naturally rises due to the density differential to the dry cooler outside air. This moist air buoyancy produces an airflow through the tower. Now, this is the airflow which is generated. In the mechanical draft, a fan induces airflow through a tower. A fan is deployed, which may be centrifugal, and it creates the draft of air through water getting filled from top. And this represents drift loss. The hot water comes from the condenser and through cold water accumulated in the basin, it is taken back to condenser system. Friends, once again, the functioning of cooling tower. A cooling tower is an equipment used to reduce the temperature of water stream by extracting heat from the water and emitting it to atmosphere. Cooling towers make use of evaporation whereby some of the water is evaporated into moving air stream and subsequently discharged into the atmosphere. As a result, the remainder of the water is cooled down significantly. Cooling towers are able to lower the water temperature more than devices that use only air to reject heat, like the radiator in a car, or and are therefore most cost effective and energy efficient. The basic component of cooling tower include the frame, casing, fill, cold water basin, drift eliminators, air inlet, louvers, nozzles and fans. Frame and casing. Most towers have a structural frame that support the exterior enclosure, that means casing, motor, fans and other components. With some smaller design, such as some glass fiber unit, the casing may be simply be the frame also. Friends, two type of filling materials are used in the towers. Most towers employ fill made of plastic or wood to facilitate heat transfer while maximizing water and air contact. The water flows through the filling material slowly towards bottom. There are two types of fill. Splash fill. Water falls over successive layer of horizontal splash bars, continuously breaking into smaller droplets, while also wetting the fill surface. Plastic splash fills promo- promote better heat transfer than wood splash fills. Second, film fill consists of thin, closely spaced plastic surfaces over which water spreads, forming a thin film in contact with the air. These surfaces may be flat, corrugated, or honeycombed, or of other pattern. The film type of fill is more efficient and provides same heat transformer in the smaller volume than the splash fill. Friends, the diagram here and the picture here shows how the space fill provides better contact with the water for short time. Friends, this picture shows a film fill material. Friends, here is the recommendation from the expert where relatively clean water will be circulated over the tower and good maintenance procedure will prevail. Either fill or splash fill may be used with equal confidence. This will be the expected condition in the majority of normal application. Conversely, where appreciate contamination of the circulating water is anticipated, only space fill should be considered. Typical industries of concern would be food processing, dairy, hydrocarbon processing, steel production and foundries, paper processing, ammonia stripping, and processing of soaps and cosmetics. Beyond this typical industry, any other any tower which will be required to operate in a dusty or wooden environment or whose makeup supply will come from unclarified water is a candidate for splash fill. Where doubt exists, your nearest Marley cooling tower or another manufacturer representative should be contacted for glass guidance. Friends, now something about cold water basin. The cold water basin is located at or near the bottom of the tower and it receives cool water that flows through tower and fill. The basin usually has a sump or low point for cold water discharge connection. In many tower designs, the cold water basin is beneath the entire fill. In some forced draft counterflow design, however, the water at the bottom of the fill is channeled to a perimeter trough that function as the cold water basin. Propeller fans are mounted beneath the fill to blow the air up through tower. With this design, the tower is mounted on legs, providing easy access to the fans and to the motor. Friends, at the end, uh, let us see some portion or component of the cooling tower. First one, drift eliminators. These capture water droplets inherent in the air stream that otherwise would be lost to the atmosphere. Water loss, air inlet. This is the point of entry for air entering a tower. The inlet may take up an entire side of the tower in the cross flow design or be located low on the side of the bottom of the tower counterflow design. We'll see all this classification of cooling tower in another series, another module. Louvers. Generally, class flow towers have inlet louvers. The purpose of louver is to equalize air flow into the fill and retain the water within the tower. Many counterflow tower designs don't require louvers. Nozzles. These spray water to wet the fill. Uniform water distribution at the top of the fill is essential to achieve proper wetting of the entire fill surface. Nozzle can either be fixed and spray in a round or square pattern, or they can be part of rotating assembly as found in the some circular cross-section towers. Uh, Friends, thanks for watching this presentation of the module by VK Jain. Thanks once again.